Question 5. Write the following in the form 5 to the power of p, where p is an element of the quotient set. So p, which is the index or the power, the p can be a positive number, a negative number, a whole number, or a fraction, or indeed a decimal, but we tend to use fractions when we're doing these questions. So we want to rewrite each of these numbers with a base of 5. So we want to rewrite 25 as 5 to the power of something. We want to rewrite the square root of 125 as 5 to the power of something. We want to rewrite the cube root of 5 as 5 to the power of something. And then hence, which means using your answers that you've just worked out, we will solve the equation 25 to the power of x equals the square root of 125 divided by the cube root of 5 all raised to the power of 12. So solve means find x, so we're going to try and figure out what this x value is. So part 1, we want to rewrite 25 with a base of 5. So 25 is equal to 5 squared, because 5 times 5 is 25. So hopefully you knew this already, but if you didn't, you can just stick into your calculator 5 to the power 1, 5 to the power 2, 5 to the power 3, 5 to the power 4, and so on, until you get the numbers that you're looking for. So 25 is 5 squared. So we've written 25 with a base of 5. So it's now in the form of 5 to the power of p. Next, we're going to work out the square root of 125. So the square root of 125 is the same thing as 125 raised to the power of a half. The square root of anything can be written to the power of a half. 125 can be rewritten as 5 to the power of 3. So again, if you did not know this, you can just put into your calculator 5 to the power 1, 5 to the power 2, 5 to the power 3, and so on until you get to 125. Notice that I've included brackets here. This is very important. So I've rewritten 125 as 5 to the power of 3, but that is still raised to the power of a half. And in indices, raising a power to a higher power, we must multiply the powers. So we're going to multiply the 3 by a half. So 3 times a half is the same thing as a half times 3, and a half times 3 is the same thing as a half of 3. So 3 times a half, or a half times 3, is going to be 1.5, but we like to keep it as a fraction, so it's going to be 3 over 2. So if you didn't know this, you could just stick into your calculator 3 multiplied by a half. So 3 times a half is 3 over 2. So the square root of 125, written in the form of 5 to the power of p, which means a base of 5, is 5 to the power of 3 over 2. Next, we want to work out the cube root of 5, again written as a base of 5. And the cube root of 5 is 5 to the power of a third. The cube root of anything is going to be raised to the power of a third. So just like the square root of 125 was 125 to the power of a half, the cube root of 5 is going to be 5 to the power of a third. And likewise, if you got the fourth root of something, that would be raised to the power of a quarter. If you got a fifth root of something, that would be raised to the power of a fifth. If you got the sixth root of something, that would be raised to the power of a sixth, and so on. So square root is to the power of a half, cube root is to the power of a third. So we've worked out part 1, 2, and 3. Now we're going to solve this equation, and remember, hence means using your answers that you just worked out. So here's our question that we want to solve. 25 to the power of x equals the square root of 125 over the cube root of 5 raised to the power of 12. So we know already that 25 can be rewritten as 5 squared. The square root of 125 can be rewritten as 5 to the power of 3 over 2. And the cube root of 5 can be rewritten as 5 to the power of a third. So we have 25 to the power of x becomes 5 squared raised to the power of x. Notice I've used brackets. This is very important. The square root of 125 is rewritten as 5 to the power of 3 over 2. We still have our division line. And the cube root of 5 is written as 5 to the power of a third. And notice I still have the brackets, that's very important. And I've brought down the power of 12. So 5 to the power of 2 raised to the power of x. So raising a power to a higher power, we multiply the powers. And then over here, we're dividing powers with the same base. And the rule for dividing powers with the same base, in this case the base is 5, we subtract the powers. So it's going to be 3 over 2 minus a third. Notice I still have the brackets and it's still raised to the power of 12. So multiplying the powers, so 2 multiplied by x, a number times a letter, we stick them together, so I get 5 to the power of 2x. And then subtracting the powers, 3 over 2 minus a third gives us 7 over 6. Notice again, I still have the brackets and it's still raised to the power of 12. So ultimately what we're trying to do is eventually have 5 to the power of something on the left of the equal sign and 5 to the power of something on the right of the equal sign. And when we have that, we can cancel out the bases, we can cancel out the 5s and let the powers equal. And then we can solve for x. So the left hand side, we have the 5 as a base, so that's ready to go. But on the right hand side, we just have to sort out these powers. So we're raising a power to a higher power. So just like up here, raising the power to the higher power, we multiplied the powers. We're going to do the same with these powers here. So it's going to be 7 over 6 multiplied by 12. And 7 over 6 multiplied by 12 gives us 14. So we have 5 to the power of 2x on the left of the equal sign, 5 to the power of 14 on the right of the equal sign. So now we can cancel the bases, we can cancel out the 5s. So the bases get cancelled, and then we're going to bring down the indices, we're going to bring down the powers and let them equal to each other. So we're going to have 2x equals 14. So now we want to get the x on its own, so the number stuck onto the x is 2, so we're going to divide both sides by 2. So 2x divided by 2, the 2's will cancel, leaving us with x, and 14 divided by 2 will be 7. So x is equal to 7. So we were asked to solve the equation 25x equals the square root of 125 over the cube root of 5 raised to the power of 12, and we got x is equal to 7. If you want to check if this is right, put into your calculator 25 to the power of 7, because we reckon that x is a power of 7. And that should be equal to what's on the right of the equal sign. So if you also put this into the calculator, you should get the same answer. If the equation is balanced, then our x is correct. Question 6. Write the following in the form 7 to the power p, where p is an element of the quotient set. So we want to write 49, the cube root of 7, and the square root of 343 as 7 to the power of something. So as a base of 7 with a power. And the power can be from the quotient set, which contains the natural number set and the integer set and the quotient set. So natural numbers are positive whole numbers, so the power can be a positive whole number. Integers are positive and negative whole numbers, so the power can be a positive or a negative whole number. And the quotient set contains fractions, decimals, percentages, ratios, and so on. But when we're doing these questions, we tend to just leave them as fractions. So the power can be a fraction. Then hence, which means using your answers you've just worked out, we're going to solve the equation 49 to the power of x minus 4, which is equal to the square root of 343 over the cube root of 7, all raised to the power of 2x. So we're going to try and find x, get x on its own. So part 1, 49, we want to rewrite that as a base of 7. So hopefully you know that 49 is actually 7 squared, which means 7 times 7. But if you didn't, just put into your calculator 7 to the power 1, 7 to the power 2, 7 to the power 3, so on, until you get the number you're looking for. In this case, 49 is 7 to the power of 2. Next, we want to rewrite the cube root of 7 as 7 to the power of something. Now notice that this 3 is a little 3. It's not a big 3 stuck in front of the root. It's a little 3. So this is the cube root of 7. And the cube root of anything can be rewritten as that number to the power of a third. So the cube root of 7 is going to be 7 to the power of a third. The cube root of any number can be rewritten as that number to the power of a third. Next, we want to rewrite the square root of 343 as a base of 7. So first of all, we can rewrite 343 as 7 cubed. And this is a number that I don't expect you to know off by heart or to recognise necessarily, such as 49. So all you have to do in this case is put into your calculator 7 to the power 1, 7 to the power 2, 7 to the power 3 and so on. And very quickly you'll get to 343. So the square root of 343 is the square root of 7 cubed, because 7 cubed is 343. So we have 7, but we don't have it as a complete base. We have this square root in front. So we need to get rid of this square root because we would just want 7 to the power of something. And the square root of anything can be rewritten as that number to the power of a half. Just like the cube root of anything can be rewritten as that number to the power of a third. The square root of anything can be rewritten as that number to the power of a half. So 7 cubed, we bring it down. Notice I've got brackets around it. This is going to be raised to the power of a half because the square root of anything can be rewritten as a power of a half. The brackets are very, very important. Next, what we're going to do is raise a power to a higher power. So when you have two powers and a bracket in between, you're raising a power to a higher power. And the rule for raising a power to a higher power is you multiply the powers. And 3 times a half gives us 3 over 2. So 7 to the power of 3 multiplied by a half is 7 to the power of 3 over 2. So the square root of 343 can be rewritten as 7 to the power of 3 over 2. Now we have a base of 7. So we've worked out part 1, 2 and 3. Hence, which means using your answers you just worked out, we're going to solve the equation 49 to the power of x minus 4 is equal to the square root of 343 over the cube root of 7 raised to the power of 2x. So my first step is just to write out the equation again. So we know that 49 can be rewritten as 7 squared. We know that the square root of 343 can be rewritten as 7 to the power of 3 over 2. And we know that the cube root of 7 can be rewritten as 7 to the power of a third. So the idea here is we want a base of 7 on the left of the equal sign, a base of 7 on the right of the equal sign, and when the bases are matching, we can cancel the bases and let the indexes or the indices or the powers equal each other and solve for x. So we're going to rewrite 49 as 7 squared, so we got that from up here, part 1. Notice that I have brackets around the 7 squared. This is very, very important. Then we're going to rewrite the square root of 343 as 7 to the power of 3 over 2. So we got that from part 3. That's divided by, we still have our division symbol, the cube root of 7, which we rewrite as 7 to the power of a third, which I got from over here, part 2. I'm bringing down the brackets, that's very important, and I still have raised to the power of 2x. Now, raising a power to a higher power, we multiply the powers. So it's very important that those brackets were there, because otherwise we would have just stuck the 2 to the x and forgot about the minus 4. You're raising a power 2 to a higher power, x minus 4. So the rule is you must multiply the powers. So we're going to do 2 multiplied by x, and then we're also going to do 2 multiplied by minus 4. So I've set that up here, but I'll actually do it in the next step. Over here we have 7 to the power of 3 over 2 divided by 7 to the power of a third. So we're dividing powers with the same base. The base is 7. So the rule is we subtract the powers. So it's going to be 3 over 2 minus a third. So we have 7 to the power of 3 over 2 minus a third. Notice I still have the brackets because that is all going to be raised to the power of 2x. So multiplying out the powers, 2 times x is 2x, a number times a letter, we stick them together, and 2 times minus 4 is minus 8. So we have 7 to the power of 2x minus 8 on the left of the equal sign. Then 7 to the power of 3 over 2 minus a third gives us 7 over 6. So we have 7 to the power of 7 over 6. Because subtracting the powers, we got 7 over 6. We still have the brackets, very important, and we bring down the power of 2x. This is a power, it's not stuck onto the back of the bracket, it's a power. So that's why it's up high. In the next step, we're raising a power to a higher power, like we did up here. So we're going to multiply the powers. So on the left hand side, we still have the same thing, 7 to the power of 2x minus 8, we just bring it down. And then 7 to the power of 7 over 6, raised to the power of 2x, we're going to multiply these powers. So we're going to do 7 over 6 multiplied by 2x. So a number times a letter, what we do is we multiply the numbers, so it's going to be 7 over 6 multiplied by 2. You can just stick that into your calculator, and then we're going to stick on the x. So again, we just bring down the left hand side, nothing to do there. And 7 over 6 multiplied by 2x is 7 over 3x, so 7/3 x. Now we see the bases are the same. We have a base of 7 on the left and a base of 7 on the right. And what we can do now is cancel out the 7s, cancel out the bases, and let the powers equal to each other. We'll let 2x minus 8 equal to 7 over 3x, and then we'll solve for x. So I'm just bringing these over here to the right hand side. So I have 7 to the power of 2x minus 8 equals 7 to the power of 7 over 3x. And you can see now I've cancelled out the 7s. I've cancelled out the bases. So I'm going to bring down 2x minus 8 and let it equal to 7 over 3x. So as I said, I'm bringing down the 2x minus 8 and letting it equal to the 7 over 3x. Now the reason why I have circled some of the terms is at this point we want to solve for x, get the x on its own. So we're going to do letters on the left, numbers on the right. So the 2x has a letter attached to it, so it's already on the left, so we leave that where it is. The minus 8 is a constant, it's a number with no letter attached. So we're going to bring the minus 8 over to the right of the equal sign, and it will become plus 8. On the right hand side we have 7 over 3x, which is a letter attached, so that needs to come over to the left. So that will become minus 7 over 3x. So again we bring down the 2x, the 7 over 3x comes over the equal sign and becomes minus 7 over 3x. All the letters are now on the left, so we can write down our equal sign, and then that minus 8 comes over to the right because the numbers need to go on the right. So then 2 minus 7 over 3, you can just stick that into your calculator. That gives us minus a third, and we still have x stuck on, and that's still equal to 8. So remember, we're trying to solve for x, get x on its own. We have minus a third stuck onto x, so we're going to divide both sides by minus a third. So dividing by minus a third on the left, minus a third divided by minus a third will just cancel, so we can cancel out the minus a third. So we'll just be left with x. And then 8 divided by minus a third, you can just stick that into your calculator. And that gives us minus 24. So x is equal to minus 24. So our question asked us to solve for x, solve the equation. So 49 to the power of x minus 4 equals the square root of 343 over the cube root of 7 raised to the power of 2x. So if you sub in that x to be minus 24, so if you have 49 to the power of minus 24 minus 4, which would be 49 to the power of minus 28, if you put that into the calculator, your answer should be the same if you put into the calculator this raised to the power of 2 multiplied by minus 24, which would be the power of minus 48. You should get the same answer on the left of the equal sign as is on the right of the equal sign. Your equation would balance, so therefore your answer x would be correct.